Just wait for 1 or 2 more minutes if everyone joins. Meanwhile, you can ask me questions regarding like what we discussed yesterday and perhaps what you think are the challenges in Indian condition for traffic signal one. Motorways are obvious, but signal one. Apart from data collection. Adapt the techniques from overseas and how to implement them. Okay, I. Mhm. 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 Okay, but apart from that, in terms of the behavior difference that you see between Indian and the pedestrian behavior, oh, what is IPTs? Okay, e-rickshaws. Okay, okay. So the unnecessarily too much friction on the road. Okay. Mhm. 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 Yeah. 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 Mhm. 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 Yeah. Mhm. For them. Okay. Mhm. 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 Okay. So no fear of facility. Yeah. Yeah. Mhm. Yeah. Okay. So maybe what we should do is we should think of an hypothetical scenario, ideal scenario. You have the data you need for signal. You don't have a side friction unnecessarily, so you are able to enforce things so that you don't have too much, like you don't have a rickshaw man starting stop having a bus, the rickshaw stop at the intersection itself. You're able to clear that and you have less side friction. But obviously you cannot have that, you cannot totally remove the heterogeneity out of it. You will have the cars, bikes, and also e-rickshaws there. So what I'm going to discuss now until like end of the first lecture. Afterwards, we will discuss under that hypothetical scenario what learnings we can get from overseas that can be applied, or what are the areas where we should be focusing on as a researcher or as a practitioner, that if we have to adopt that, if we have to implement that in Indian condition, we can think of some imaginary scenario, right? But is it possible, like if we're able to get rid of those issues which we can get rid of by enforcement, can we still do something, right? So that's what we'll discuss it now. So please keep this in mind. I didn't plan for this, but because the guys didn't start us out, let me ask a question. So yesterday we started the discussion on traffic signal, and I will be honest, I was very struggling to figure out what to present, what not to present. With the case of VSL and RAM metering, it was much easy because I know it's not taught in the Indian condition and you don't have much experience on that. So I went to the fundamentals and all those things, especially fundamental diagram and another aspect. With respect to signals, I know in the undergrad program you are taught how to design the signal as such, but I want to figure out what can I cover from the Australian experience that we can bring on plate so that we can initiate this kind of discussion. That's the objective. We talked about a design process. There is one process. You talk about design, you talk about signal phases, maybe define phases. Intergreen time, you specify how much time you need for for the transition from one phase to another phase, given the width of the road, given the width of the vehicle or length of the vehicle, etc. We talked about a cycle time. Yes, you can borrow an optimization equation from Webster or some other means to get a cycle time that you want to specify. Also, the specifications defined by your jurisdiction, like Indian Standard Code that you're talking about also has some specifications. There must be some improvement done down the line. So each jurisdiction will have its own requirement that you have to satisfy when you are an engineer designing the signal for that area. Then we talk about green splitting, a very simple approach. I'm going to give green to the approach where I have more demand. Very simple. You define the cycle, the entire let's say pi. The share of the pi should go higher to the approach where there is more demand. With certain restriction, you want to have some minimum amount of green also to serve pedestrians. Although I did not discuss pedestrian, but each time when you are giving an approach and you are giving a pedestrian one also, the minimum is specified. Then we talked about we didn't talk much about the performance evaluation, but you will evaluate the performance once you have designed the signal and keep on fine tuning it. That was the process we discussed yesterday. Now today I am going to talk about phases first, the first process. The phase, as you know, you have different movements. Basically you try to combine certain movements together to give the right of the way to enter the intersection. That's what the phase is. Signal phase is generally defined as the right of the way in a cycle that is assigned to an independent traffic movement or combination of traffic movements. This must account for the lane use and the traffic volume as well as the opposite traffic volume. So basically safety plays an important role when you are designing the phase. We have also seen you do not want to have large number of phases, too many phases, because too many phases are going to contribute to the lost time, and that's not an optimal thing. Also, you cannot have too less phases, then you will have an overlap happening, or let's say the movements which can have an accident. So you want to avoid that too much overlap also from a safety perspective. So there is a balance between the two, between efficiency and safety, and you as an engineer has to make a decision what to do for that corridor. There are different ways of defining the phases. Phase-based approach or stage-based approach is what I was discussing. That is one way of doing it. And the other ways of doing it is a ring and barrier control. The third one is the group-based control or a movement-based control. It all depends on which country you are in and what they have followed. US, Canada, North America following the ring and barrier. Australia, Japan, China, UK, I believe also in India, we are following the phase-based control. Whereas if you go to more the European countries, they are following more of a group-based or movement-based control. How many of you are aware of these three, the differences between them? Okay, so we'll discuss about what these three are. First one we have already discussed. So we already talked about the first one yesterday, that you have an intersection, define the phases. I have defined 4 phases. We can have a 3, 2, whatever you want to specify. That depends on the geometry of the intersection, the demand profiles, and all those things. The past incident records on that one. That was straightforward, and at the end of the day, you might be displaying the green attached to the phase. In the other case also, whether you go for the NEMA ring barrier or a group based, you will have a display phase sequence. So let me talk about the NEMA ring barrier. This is from US, so right hand driving is there, so please keep that in mind. So it's different from the way we drive here. In the US practice, what they're doing is they organize the phases by grouping them in a continuous loop or a ring. So like here you have, in this case you have 2 rings, the top ring and the bottom ring. So think of them as 2 separate rings, right? And then and separated by crossing or conflicting traffic streams with time between when they are allowed to operate, either by making the movements sequential or adding a barrier between the movements. What it's saying is that I have phase 1, phase 2, phase 3, phase 4. So these phases you have to specify as an engineer. You will specify these are phases I want. But if you look at a specific ring, the top one, none of these can go together. I will not let my left turner to go with the other phase left turner. They are right hand driving, so I think it's a bit, you might not be able to imagine, like it's same like our right turner to go with the other movement right turner, for example. So this is what you specify, the top one. Then you have a barrier in between. So what this barrier is saying is these ones will not should not ever combine with the other ones. So let's say the left portion of my ring, the top ring, should never combine with the right portion of the bottom ring, and vice versa. So that's why you put a barrier here. Are you okay with this? Ring and barrier? But you can have a combi. 1 and 5 can a combi, 1 and 6 can be a combi, 2 and 5 can be a combi, 2 and 6 can be a combi. That's what the ring barrier is all about. It gives you more flexibility. In the previous case, when you are looking at this, once I have defined the phase, I have defined the phase. I do not have much flexibility in that case. If I am defining the phase like this, we can adjust that also. We'll discuss that later on. But here the phases are fixed. In this case, you are adding a bit more flexibility in the way you are operating, right? Well, when you talk about this, the phase-based guy said, no, we are also smart enough. We can also make some combinations in a smart manner. Don't say that the ring and barrier is the one having a lot of flexibility. We'll show that later on. So in this case, you can see there is there are some protected phases and permissive phases. So when you say protected means, if let's say here, if I am taking a right turn, for example, I will have if I have a right signal, it means that is my priority to go. I can take a right turn. But if I do not have a right turn arrow and it is not also red, it's just a green for through, it means that I can take a right turn, provided the guy coming from the other side we have sufficient gap to make a right turn. So this is called as a permissive phase. So permissive phase is like, if I am, let's say there is how to say, I'm going, there is a through and the right movement. If this right movement is pervasive, means this one will enter only when the other approach has sufficient gap and you are able to enter. So you are allowed to take a right turn provided that there is a sufficient gap in the other direction to enter. So you are allowing a risky behavior, because a right turn and a through from that can have an accident. You are allowing that behavior because you do not have too much demand on the other approach. So you will have some safe gap that they can move in. So you can allow that. So basically it's not that you will never allow a right turn and a through. You can allow that provided that there is sufficient gap you observe that it is possible. If it is not possible, you will not do it. Then you will make it a protected phase. You understand the difference? Yeah. In fact, when you have no signals, and you're trying to make right, you're always in the permissive phase. In this case, like in India, or maybe you believe that you are always in the protected phase. But I hope you understand. So basically, what you're doing here is the dotted means this guy is because this is a right hand driving. This guy is allowed to take a right turn, provided there is a gap in this one. Similarly, this guy is allowed to take a right turn, provided there is a gap in that one. Yeah. Oh, when you are a driver, if this is the, let me draw it actually. Suppose it's like this. Suppose I have an intersection and this one is through and right. If I have if I'm giving a if I'm giving a protected one, or basically the permissive one, this traffic, this person can go until this point, because if I draw my lanes properly, give me 1 second. Say right, so this is your intersection. So basically this person have to go in this way, the other guy can come like this, and the car here should be following this one to go that way, right? So at the center of the intersection, the car can wait, one car can wait, one car can enter, provided you have what this car is going to do is this car is going to wait for sufficient gap in the other approach, and once, let's say, there is sufficient gap, there is no car here, this guy can go, assuming that he finds a safe gap, right? That's what the difference is. So you will let one or two, you let the vehicles go, but this you will only allow when there is less demand in this approach. If there are 2 lanes or 3 lanes, you will never allow that, because then you have too much. Even if the demand is less, but there are 3 lanes, it will be hard for this one to find that gap, and they might be aggressive, or they might take a risky turn that leads to accident. Yeah, so that site should not have this kind of accidents happening. Then only you can allow that. But you can allow that based on the demand. Because certain time of the day, you might have certain less demand profile going in this direction, high demand going in that direction. So for that time of the day you can allow it. Some other time of the day when you have a high demand going in this, you will not allow that. So it's a decision you will make as an engineer about that site, and based on the demand profile for the site. You need to have understanding of the intersection geometry. You need to have understanding of the demand profile also. Sometimes the intersection is too small. You say, no, it's unsafe. I can't do that. I won't allow that. So there is a lot of engineering judgment that you apply. It's not one approach which can be applied blindly on all the intersections. It's never that case, because none of the intersections are almost all the intersections are unique. You don't have the same intersection profile even in the same city. Yeah. I should rub this actually. So now let me say how that ring and barrier is giving you the benefit, giving you more flexibility. When I say here, imagine this is a fixed phase sequence. Ring and barrier is, this portion is a barrier. Okay, this is barrier. These can move. So I can cut. So let's say this is my phase 1, phase 2, phase 3, phase 4, 5, 6, 7, 8. For example, I am giving phase 1. I will give phase 1 that much green, but I can give phase, let's say this phase less green. I can start the other phase. So if I do that way, this is the combination I am getting. This is my display signal phasing. When I say display, means this is what you are putting on your signal lanterns, right? Or I can do the other way around. I can shift things. I will have another combination. So you can have different combinations possible, right? So that's the benefit you are having. So link and barrier has slightly additional degree of freedom compared to the phase base one. Yeah. So let's say these are the two conditions. This is one kind of display, there's another display. So what's happening here is you have a through and left, and here you have a left and through, and then you started your right phase also, and then you have started your combi of that one, right? And then, but this was a barrier. This one will never collaborate with that one. So there is a solid barrier in between, and then you have this combination. So you start with a phase, these two phases in the beginning, but the duration of these phases depends on whatever demand is there. You end with those two phases, then your cycle finishes, and then you start again. That's a ring and barrier approach. It all depends on the controller that you are using. So NEMA controllers are designed that way, right? And this is how you design the phases for that condition. Now, jump between the two means. So what you're saying is, for example, in the first cycle I start here, right? I'm also starting there also. So it's not like so basically this, think of this as a time. So when the time is moving, you are using one combi from here, other combi from there, or one of the phase from here, that's there. So I start with phase 1, I'm starting with phase 5. Let's say there is not much demand for phase 1, I can early cut phase 1, then I go to phase 2, but I can still continue phase 5 until I reach my barrier. So the beauty is these two rings can work independent of each other, and that independence gives you that combination. Sorry?
phase 3, phase left cannot come together.
Can never come together, should never come together because of the safety concerns. Number 2 and 5 is having a conflict? No. So in fact 2 and 5 doesn't have any conflict because think of 2 is this one is turning right, this one is turning through, this is the left turn of 2. So if you have 2 and 5 together, it means you are giving all the 3 movements of that one to go. Yeah. 5 and 6 cannot be in the same ring. That's why this is a ring. You should not be combining these two together. You should not be combining and and similarly you should not be combining one portion of your barrier with the other portion of the barrier. That's why you call it a ring and a barrier. You design it. In this example, they have used a permissive phase. You say, no, I don't want a permissive, I want a protective and I want a separate permissive. That's another phase you are specifying. So at the end of the day, you have to define the combination of the movements that defines the phase.
So that is depending upon the number of lanes also.
Number of things, yes, number of lanes, the demand. So because this one is designed for an intersection, right? For that intersection, you have to understand the geometry first. What's the geometry of the intersection? Then what is the traffic composition for that one? Then for that traffic composition, you define what should be the phase sequence and all those things. So that was for the ring and barrier. I borrowed this from one of the Eclipse slides from Sidra Solutions. Signal phasing sequence, when you're doing a phase based approach, right? You can combine different phases. For example, here, it's a through with the right turn filters. So now this is for the left hand driving, by the way. So both the throughs are allowed and both the right turns are also allowed with some filter, right? So basically these are permissive ones. I can define this as one of my phase. Now I'm talking about the phase sequence, right? I can define my phase and I can define my sequence so that I'm able to serve the kind of movement I want to serve. Here I can have a leading right turn, means I'm giving a right turn first, and so this phase if I display first, I'm letting a through movement with the right turn. After that I am letting the through to go, but I have stopped my right turn and I am letting my through movement for the other direction, right? That is another combi you can think of. Similarly, you can have a lagging right turn. In this case, you have both these through happening, but you are also making sure that the right turn here is not allowed. And after that one, you stop this through and you let the right turn go. This is something you can play with the display, but by doing so, you are having an overlap happening. Overlap means I'm not shutting up my through movement, I'm letting the through movement to continue in these cases. So this is one, basically we talk about the split approach where there are two separate ones, there is no overlap, there is a total split, the other ones have some kind of, these have some kind of overlap. You can have a lead lag right turn, in this case right turn leads, after a while the through starts from the other approach, then you have a right turn for the other approach and this stops. So this is a lead right, that's a lag right. So lead lag combi. You can have a repeat right turn. Repeat right turn means I have a through in the right, I allow the other guy to come, then I stop it and I still allow the right turn again. These combinations you can define. But safety, you have to consider the safety of that site in mind, you consider the traffic behavior in mind to make these kind of combinations. Then the last one is the diamond overlap. It's an interesting one, but I will show it in the next slide. This is quite interesting, diamond overlap. I have two right turns allowed. This let's call it phase A. In the case of phase B, I have a two variable phases, B1 and B2. B1 is I am basically having a through and the right turn for one approach, B2 is the other one. And based on my traffic conditions, based on the way I have defined the rules, I might either go at B1 or I can go at B2, or I can even go skip B and I can go to C. So these are the flexibilities you can assign in your software to choose. But phases are not, the phases are defined the way they are defined. Then you have a C, then you have a D, and then again the D is following some other combination, like you have a two E's, E1 and E2, and you have a phase F. So now I have A to F phases in front of me. I even have variable phases for actually B, where I can make a decision to go. So you can think of the number of sequences that can be generated from here based on the demand profile, right? So the phase based guys say, look, yes, ring and barrier, yes, you can do things, we can also do that thing by adding some more intelligence into it. Yeah. Now this is, I have borrowed exactly from one of the intersections in Queensland. So that's the phase diagram at the top for this intersection. So you have a phase A, which is saying I will let the through go, but I will not let these two through, I will let them go. I will not let the other movement happen. This one is for the pedestrians. So I will let these two pedestrians also go when I am giving these two through movements, but I will not let the other through to happen. That's your phase A, very safe phase. There should not be any kind of accident, right? Phase A. Phase B is I am now letting this through with the pedestrian approach here. That's phase B. Phase C is I am letting the other through with this pedestrian movement happening. That's the phase C. Then phase D is I can have this right turn going up. Even the U-turn is actually allowed in this particular case, so I can have the right turns going up, but and then none of the others are happening. Phase D1 is I'm having a right and through with the pedestrian there, and phase D2 is I have a right and through with the pedestrian there. Again, you as the engineer have defined this for that site based on your engineering judgment, based on your knowledge about the site. Yeah. Now this is actually whoever have designed that intersection, also this is a kind of a signal design plan or the phase diagram that they specify. So the one that you are looking here was actually that top one, right? And in fact, each of these, so each intersection should have this kind of plan. These are standard there. So and that plan includes the details of the intersection geometry, how the intersection really looks like, and it talks about where the loops are. For example, I have a loop here, I have a loop here, I have a loop here. The location of the loops are also specified for that intersection. You even know where I have the signal post and other things. So all the details are actually provided for that site. And the one you see at the top is the phase diagram. So if I zoom it in,
So, this phase diagram is defined after they have the making count of the intersection.
oh yeah, this is basically intersection is built. They know the demand and all those things, and then they have defined. So phase diagram. I mean, if there is hardly is a brand new intersection, you would have done a study beforehand that a signal intersection I'm talking about, that I need a signal intersection there. So there is a business case that I need to implement. I need to have a signal intersection. So people would have gone down and basically did the volume study and all those things. So based on that, you have defined the signal plans. So it is based on that one. Or you already have implemented things. After 1 year of signal operation, you find the signals are not performing well, you have to redesign the signal timings, and that's upgrade. So when the upgrade is done, and then you submit your plan accordingly. Yeah, like for example, phase 1 is linked with the vehicle group 1 or the movement 1, sorry, of phase A. Movement 2 is linked with the vehicle group 2. So all these details are properly mentioned there.
Vehicle group means
Oh, vehicle groups means it's a vehicle group movement. They can be two separate movements. Like this is a vehicle group movement, that's a pedestrian movement. So there are like PG1, pedestrian group 1 for that one. PG2, that's a pedestrian group 2. for actually 8-1.
Vehicles here means only 4
Yes. So vehicle here, these are basically generally they are defined for the vehicle movement. It doesn't matter whether it's a 4 or 2 wheelers, but they are mostly 4 wheelers. They are not optimized for cyclists. They are not optimized for e-scooters, etc. There are some trials done where they are trying to consider the cycle green wave also, and I will discuss that later on. But traditionally and currently in almost all the intersections, it is designed for vehicles only, and that's a big discussion going on. It's not about the mobility of the cars, it is the mobility of the people. And if you want to go towards more sustainable transport, you have to design the signals for that sustainable mobility also. We had a project with them to understand what are the ways by which we can gather those, because I can design my smart signal in academia or in papers easily, assuming I have a data. But the data you have is only from the loops for the cars. You have no understanding about the pedestrians that easily. You have certain sensors, but not installed at the intersections. So there the issue is that we do not have the understanding of the non-cars. Here the issue is that we don't have a data at all, but the issue is there. Like one turn is you have the data, you can't make that decision. Now, important part which I want to highlight here is the conflict table. Conflict table is a very important table that you specify for the intersection. Like the ring and barrier. The barrier totally defines that, okay, there is a big conflict. You should never let them go together. So, I think I have another slide which talks about conflict table in detail. And next one. Here. Conflict table. It says that my vehicle group 1 should never go with vehicle group 3, should never go with vehicle group 4, should never go with vehicle group 6. And that's a hard coded in the intersection controller. That's the safety layer you have. That should never, because see, at the end of the day, all these things are done electronically, right? There are loops, and in the previous case, there's some information about which cable connection is with all those things, right? All the details are there, but then electronically. But this is the most important one. That is the safety one that you specify. So conflict table is the one that you are using for both group based and the NEMA case. You specify that for the intersection, and conflict is based on the safety requirement. So you cannot have a group 6 with the vehicle group. So vehicle group 6 with actually a group 1, or vehicle group 6 will never go with a ped group 1 because of safety reasons. That's another complicated example. Phase A, phase B, phase C, D, E, D1, D2, E, F1, F2, phase G, G1, G2. So many combinations designed for the intersection. Yeah, it's a bit more complex intersection. It has a slip lane also. So what I'm trying to tell you is each and every intersection has its own complexity. You have to look at it with your fresh eyes and the knowledge you might have from designing the previous intersections. Yeah, it's a very complex job. It's not an easy job. That was for the phase group. Now I'm going to talk about a further degree of flexibility, which is, they said, the group based or the movement based controller. There I don't care about phases. What I care about is, give me I can group my movements together. Ultimately what you're doing is, in the previous case also, you might have grouped your movements to form a phase. I said, let the movement be whatever, let this be one movement, let that be another movement, let this one will be the third one. Let's have the movements like this. Let's have them in the bag. Based on my need, I will just extract some of them and let them go. That's what this group base is doing. But in this particular case, you have an intergreen matrix. So intergreen matrix says that if I am having a group K1, I'm finishing K1, I can start K2, but K3 should start 4 seconds after that. There should be a 4-second intergreen between K1 and K3. And in fact, we talked about the green time and all that time. This is the one which is considering that one. And you have to design it for that intersection based on your geometry of the intersection, based on the speed limit of the intersection of the road, based on the pedestrian speed and all those things. So that has to be designed for the intersection. So this is totally lot of degree of freedom. Why do we need that? When do we need that? Sorry? But vehicles will arrive, whatever, like, let's say they will arrive in whatever form. If there is equal traffic in all approaches, this thing will end up same as the phase group, a very fixed phase group. See, if the traffic is equally coming from all the approaches, ultimately the combination, the optimal combination that you get from here will be similar to the phases that has been optimized, right? So yes, you might be picking them from a pool, but the optimal pool will be same as the optimal phase you have defined. It will not be a very big difference. This one has, see, in the previous cases we talked about the flexibility. Like I started with the very fixed base approach. I said that that's a fixed one. NEMA ring and barrier is adding a layer of flexibility into it. But still, you have to define these phases. You don't just, they have to be defined. You can have a different ring specified based on the requirement of the intersection. So you have additional level of flexibility. Phase guy said we can add that flexibility also. Not only you can add it, but this one is saying I have a totally different level of flexibility. I am giving you full flexibility here.
We were playing with times, right?
Sorry?
We were making use of the time factor to design it.
Mm-hmm.
They are doing that at what situation is required?
What situation this is going to really add a benefit? Yeah.
When we have real time sensors.
Okay. Okay. Mm-hmm. For the other ones also we need real time sensors. Yes. The fixed base control, when you do not make any dynamic changes, you don't need a real time sensors. But let's say, yeah, let's say all of them have a real time sensors.
This group-based control has been implemented.
Oh yes, it's in Europe.
Sir, this is for intersection only.
Yeah, all of them intersection. I'm totally talking about intersections only.
Sir, when we know that there will be fixed volume on fixed routes, we can do this.
When we know that, yeah, I mean, yes, we can do this. Yes, we can. But we can do the same for the other ones also. We can do the other ones also.
Variability is so dynamic in our.
Yes, when you have so dynamic variability, then this is going to really make some benefit. I said this is in Europe. What's in Europe that is different from India, other places?
I mean, borders are open.
Oh, think of any Indian song. They are dancing in Switzerland, and you have trams and metros, all things going around, right? It's a multimodal situation. See, you have so much happening there. So the benefit is when you have so much different combinations happening, tram is coming, you want to give a priority to it, it becomes much easier to handle that way. This is a time when you need more flexibility. I think this is my personal view. I mean, you have the benefit literally when you have too much constraints. If you do not have that much constraint, the demand is equal from all the approaches, whether you use this approach, you use that approach, or you use this approach. More or less all of them will be giving the same thing. There will not be a significant difference. The benefit is only here.
The example that you're putting is on that is still at the intersection.
Intersection, yes. I mean, see that the tram, these are intersections.
Okay, so you say like I've been in Europe, so what you say like I can also see an intersection sort of
Bicycles, trams. I mean, so once you are implementing it irrespective of the fact whether you have a bicycle trams or not. You have the cars, you are implementing it, right? But I'm talking about the when do you think will be the major benefit? Major benefit will be when you have the variability in the demand coming from various approaches. Stochasticity is far high. So if you have fixed few things, they will follow certain order. You will have some lost time. Here you don't follow any order, but it's at certain cost. What is that cost? You don't follow any order. So what will happen? I mean, yes, you don't follow any order here. You will just select whatever is the highest demand you think you will select it. Sorry? Oh, in fact, in this case, the lost time is less because the way you select them is you are overlapping as much as possible. So when you are overlapping, I will give you an example actually, then you will have understanding. One of my PhD student is working on this topic. Initially, I was thinking not to talk about it, but yesterday I did a lot of massaging on my slides to figure out what to present, what not to present. So I will just give you one example. Give me 1 second. This one is that's an example from one of my PhD students' work. He is working on a traffic signal control algorithm, which is max pressure based algorithm. Just to give you a rough idea about this, it is borrowed from the internet communication things. You think of an intersection, you have different approaches. So max pressure says the one having the highest pressure, I'm going to give green to that one. And that pressure, so basically you are making a decision every certain time interval. You are deciding whom should I select. One having the highest pressure, I will select that one. So the pressure can be specified in various forms. You can say pressure in terms of the queue length. You can say pressure in terms of the delay. You can specify pressure very far. In fact, as I'm discussing, I will show you the contribution he is making, the contribution he has made so far. This is a literature review he has done to identify various literature where the max pressure has been used and what was the pressure function they have used. Pressure function is simply weight of simply the sum of the weights of the various movements for that one, and the weights are specified in terms of certain combinations. Generally, they are the queue length and etc. He tried to modify that. He studied this one and come up with his own equation, which takes into account amount of spare capacity at downstream. So like if I am going to give a green to an approach, but a downstream doesn't have enough to accommodate that, I do not want to give too much green to it, even though there is a lot of pressure here. It takes into account certain things, right? That's not what I wanted to talk about here. But what I want to say here is that he has implemented this on a group based system. And that's a slide that talks about a group based system here. Let's say it's a very simple intersection, as you see here. So you have different combinations of the groups. Let's say northbound left, northbound right. So northbound means the one going along the north direction, left, right, or through, right? Think like that. That's the name assigned. This northbound through is compatible with left, right, and left. So basically, you have this intergreen matrix, right? It tells you that K1 goes with K1, K2, K5, F1, F3. Okay, it goes that way. So what he said was, at any given time, I'm going to figure out which of my movements is having a higher pressure. So the one having the higher pressure, I'm going to select that one. That this is my primary movement I want to give green to. But when I'm going to decide that, when I'm selecting that one, let's say this northbound through is what I have selected, or maybe northbound left is I have selected. This northbound left is compatible with northbound through, northbound right, westbound left, and so on. 1, 2, 3, 4, they're like number of ones is compatible with. He said, I'm going to go to the next level of addition. I will see how much is the pressure for the other ones. So the one having the highest among this sequence is what I'm going to select. So that's how he is making his decision. So you have total flexibility up to you, how you want to select it. Got it? So this can be any combi. So you can have northbound left with the southbound left, eastbound left, and eastbound right. After a while, the queue length has changed, and perhaps you have found that southbound left, because if you have already southbound left, maybe southbound through is now having higher pressure, then you select which of these I'm going to select. So you can have any combis happening, but the good thing is when you're moving from here to there, there's a good overlap there, right? So you are able to serve more in the same time interval. But what do you think as a driver, you as an Indian driver, let's say, will feel when you are at the intersections? See, when you are going to an intersection, right? And if it's a phase based, how do you see that? You have a specific pattern in mind. Okay, if I reach now, after certain time interval, I will have 1. Here there is no pattern, which is efficient, which is really, I'm not saying it's not efficient. He has shown some results. He performed a simulation on a corridor. He tried to show some results that okay, how his model, which is called as Pascal, is performing better than other models, right? I have always said I don't talk about results here, concept that one. We will be able to show that is better than other ones. That's what the researchers will do. But the point here is that it has lot of flexibility. So if, and in fact, we can even add some extra weightage or extra weight to an approach whom I want to give a priority. So if a tram is coming, you just shoot up the weight. No matter whatever is happening, the next one is tram. So you have that flexibility with you.
He has designed these routes already, right?
So that is the intersection he is working on. So this is a intersection in Brisbane. So you know the intersection. So basically for that intersection, you might know the intersection geometry. Now this slide is not exactly the one, that one is just for a conceptual one. But because you know the intersection geometry, you know the intergreen matrix, you know which movements are conflicting. So you know that this guy is compatible with those ones. So when I am selecting northbound left, I can let my northbound through, westbound right and westbound left also go at the same time. Or with the northbound left, I can go other ones at the same time. So these are simply nothing but from this matrix. Or if I want to go to this is quite far away. If I want to go to the conflict matrix, these are the combinations when there was no cross. Yeah. So this is specified for the intersection. Like even when you are going for a group based, or sorry, when you are going for a phase based, you specify the phases, right? You specify whether it's a permissive or it's a permitted right turn or not. These are something you design. So he can design that. You can design it for intersection.
Every time he reprioritize what needs to go to.
Yes, based on the pressure. In his case, the pressure function is the amount of Q you have on that approach plus how much is the spare capacity at downstream. So he has certain weights here, like the one which is there, like the amount of Q you have on this approach compared to its capacity. So let's say if I have this link that long, if I have that much Q compared to the capacity of my one, that's my first weightage. So the closer I am to 1, it means that I'm about to spill over. So I'm going to give more weightage to this. Other one is if I'm going from this intersection to the next intersection. For example, if I'm going from here to there, if there is not much, if the Q is already until this point and your spare capacity is very small, if I do not have enough spare capacity, I don't have to give too much green immediately here because I have to flush that first. This is what happens whenever there is a spillover. You might be giving green to an approach, but if you do not look what's downstream, that is a total spillover. I mean, that's a waste of green. You don't want to waste the green. So he just tried to come up with this function here, that if this thing approaches 1, this whole thing goes to 0, your weight goes to 0. You don't want to give a priority on that one. Or you can have this one, like for example, you have the model he has developed is named Pascal. You can run Pascal here, you can run Pascal there, you can run Pascal here, you can run Pascal everywhere. I mean, you are individually running them, and they take into account whatever you have information. But here the big assumption is I know the Q length. That assumption has been made for the research purpose. For practical implementation, you need to come up with an estimate of the queue length.
So,
Yes.
Will it be difficult for coordination? Like, because the flexibility is more. So is it like better to do for isolation?
Yes, in one sense, yes, that these are quite decentralized, but they are only focusing on one of them at a time. But they are like in the case of max pressure world, it has gained interest in last couple of years a lot. So you can see from the literature, the number of papers started in 2012, almost in last 12-13 years, how many publications are there in that space, right? And his publication hopefully is going to come soon. The next one will be here, right? So you can see the publication. There's a lot of interest in that one. I know one of my colleagues in Israel, Professor Jack Haddad, he mentioned to me, I met with him recently, that they have even implemented max pressure in one of the intersections there. Based on the pressure function they have defined from travel time, right? Now coming back to your coordination one, you can always think of like, if these two, see for coordination, first thing you do is these intersections should talk to each other, means you should have a centralized way of approach, right? So you can always think of, if you want to give a coordination to a specific approach, always think of these two talking together. There's one approach where you say, okay, if the green is given here, I know how long it might take to reach there. I might give extra weightage to the downstream one for the coordination. You can always think, because at the end of the day, your lever in hand is just the weight function. You can think of that one. That's one way. Other way that people have done, they said, okay, we are going to have a totally decentralized one. We are just going to combine them like based on the travel time of that approach. We don't need to talk then, but we know that okay, that green was offered. This green should be offered after a certain time. Yeah, basically you can add some intelligence in it to get the coordination. In fact, it has been done. I mean, in Europe, if they are using it, the public transport priority system is already there. The trams, when they are going to hit the intersection, they have to be given green. So those things are there. Those add-ons you can add easily. That's the pedestrian push button. No, it is a call. So basically, I will show you when I show you the TMR system. It is a call. The pedestrians are making a call. So the controller knows that now there is a pedestrian. In fact, that is the only way controller knows that there is a pedestrian from the push traffic. Yes, there are other sensors, like there are pedestrian sensors, the radar sensors installed at the smart pedestrian crossing that can tell you that there is a pedestrian. But apart from that, the push buttons are the most widely available way to know that there is a call for pedestrian. That's all. There is a call for pedestrian. It doesn't tell you how many pedestrians are there, but it just tells you somebody has made a call. Yeah. So I hope that answers your question, that it can take any combi. But like if you are like I was having a chat long time ago with Professor Laita Vanajakshi about this one. In fact, Professor Laita Vanajakshi is the co-supervisor for the student. He's a joint PhD with IIT Madras. His name is Tamajit Ghosh. So we are working together. So we were having a chat, and and her view was in Indian condition. In fact, both of us views are, it is hard because people want to have that predictability. It will be more unsafe if we do that way for Indian condition. I should not be speaking on her behalf, but I'm saying we agree on that one. Yeah. So where was I? Yes. So it is just to do the culture also, but more important is when this is not. This is when the phases are not predictable, people might be more prone to take. But there's not any, like people have done some research, I know in Japan and also in China, to compare these two from the behavior perspective. They didn't find any significant variation. People basically adapt to it. And in fact, if their delays are minimized, they are happy. People will be taking more risky behavior when you have to stop for 10 minutes. You will hardly care about, as you mentioned, right, in 10 or 5 minutes. You want to actually break the rule. But if you're stopped for, you know that, okay, quickly I will be allowed. you are happy. Like the delay in I mean the congestion in yeah.
One other issue also might be because of the constraining number of lanes. So what the usual behavior sometimes is there is no turning lane or two lane.
Mhm.
So if all of a sudden it changes, so some people like turn from the second middle lane or from the shoulder lane also. So
Yes.
that will also be my
Yeah. That will be there, and that's why I think when you're designing your phases, you have to consider the behavior in mind. So, for example, if I had, and this is not a good one, but let's say this one, through and right, for example, I might like to combine them together. So, in Indian condition, you like to say, okay, let everybody go through. Like when I'm giving a green, let everybody go. So, you might like to define your phases in such a way so that you are considering the driver behavior of that area in mind. Yeah, so that's where you have to apply your engineering judgment. Okay, we can have maybe 2 minutes break before we start. Yeah, just touch your body. We can start next. The next I'm going to talk about the control systems, and I'm going to talk about streams arterial. Online audience, do you have any question?
You started asking some questions. She has joined.
Who is she?
Tamil. First class. Before sir.
What was the question I asked in the morning? Yeah, it was
Pedestrian all red.
yeah. So the question I was asking in the morning was during this discussion, think about. I mean, I gave an like I said to you that think about if you have to apply the traffic signal in Indian condition under certain hypothetical scenario. You have all the data with you. Don't worry about the data set. There is no side friction happening at the intersection. You have enforced sufficient so that you are not letting people to stop unnecessarily, but you do have heterogeneity in the traffic. So how will you design the traffic signal for Indian condition, right? That's the question. I said that think about it, and perhaps by the time we finish this discussion, we should finish that by getting your views that how you think should be designed based on the learning or based on things we are specifying. Like we have already discussed roughly that okay, group based, phase based, movement based, thing and barriers based. Perhaps we will not go with the group based for the Indian condition, right? Sorry, the movement based for the Indian condition, because it is so random that it will be unsafe for the Indian condition perhaps. Yeah. So traffic control systems, there are a number of systems in the market. Even in Australia, we have streams arterials, and I've talked about streams a lot in this program so far. SCATS is another system developed by like the Sydney guys, so Sydney Coordinated Adaptive Traffic System. You have Scoots in UK. I know Scoots has been implemented at few places in Delhi. Somebody told you about it. You have InSync, OPAC, ACS Light roads in US, and number of them in Europe also, like VS Plus, Motion, Utopia, Balance, and Sumimoto in Japan. Just some of the list of the tools. They are the actual systems that can help you to control the intersection by observing the traffic using the sensors, and most of them are using a loop detector or a proxy for the loop. When I say proxy for the loop, means they might be using cameras. Camera is focusing on specific location on the intersection or after stop line, wherever they have to focus on. They make a virtual loop and they detect the presence. So they're not taking the full advantage of getting the queue length and all those things. Although I talked about like our Pascal algorithm requires queue length, we don't know how to measure the queue length. We are assuming queue length will be known to us. So the sensors at this stage are loop based, or they are presence based is the one that they are using on the traffic signal control. Yeah. So I'm going to talk about one of the legacy systems. I mean, basically, on the constant state of practice, I'm going to talk about streams. Here, you have already seen this. You have already seen this image earlier or this video. streams RTL is what earlier we talked about streams smart motorways, which is VSL and RAM signal. Now we're talking about streams RTL. Here, we already discussed earlier that you have different loops, and these are the loops which are eyes on the road. Whenever the loop is occupied, you get it white. Not occupied, there is no, it's not white, it's just a single rectangle. But what you can see here is this one, this intersection is working in certain manner. For instance, yeah, its cycle time is around 120 seconds, and this is actually in terms of, imagine this is a real time, right? Cycle time is 120 seconds, offset is 38 seconds. The time, so currently you are in phase D, so phase D is giving green to this approach, and you are expected to give a green for 23 seconds. You are currently in 20th second, and after a while you go to some other phase. Now you move to other phase, right? So it's now you are at phase A. So maybe the video is stopped or what? Okay, it's okay. So here you are in phase A. Now phase demand is mentioned. So one you mentioned was PC. There was a call for a pedestrian, right? Somebody has touched the pedestrian button. So this information is known to the control in the real time, and you know that this is the intersection where I've shown you some drawings also. You might have a signal controller sitting here, and if there is a pedestrian crossing at this point, there must be a pedestrian push button that you can press. So that information is known to the controller, and controller is going to make a decision accordingly. So this is adding, like when you want to work, it's not a fixed time signal control you're doing. You are basically adding the flexibilities through it. It is working in a coordinated mode, means it must be having a green time coordination with some other approach, some other intersection. And currently is working on a specific plan, which is optimized for the heavy traffic between 8:30 to 9:45 a.m. So all the details are known from here, right? And it is the actual system at one of the intersections in the city of Logan. What is offset? It says an offset is 38 seconds. What do you mean by offset? Offset is 38 seconds. What is meant by offset? Yeah. And I said it's working in a coordinated mode, means if I'm giving, and that you should have an approach where you want to do the coordination. You should know that which approach you want. It will not be that you are coordinating all the approaches. It's too complex. One of the approach you have said, right? Imagine that this is the direction you are coordinating. So offset is means if I've given a green there, the green like in terms of the start of the green should be about 38 seconds of here. So there is a coordination done. So it might take a travel time to reach this point, and there is 38 second offset defined so that the green wave actually moves. So there are ways to do. We have yesterday discussed you can get the signal optimal timings and cycle time, green time, all those things. We will discuss how we can optimize that. But there are ways you are going to actually, now imagine you have a system where you have implemented, you have the loops on the entire corridor, you have a signal controller, and you are trying to change the signal timings without any policeman attached to it. So you can control this intersection in three ways. Isolated mode means you are just running it in isolation, master isolated, or a coordinated mode. Now isolated mode means I have defined my phases for that time period. I have defined my phases. I will select a phase based on the demand I have. So if I have a demand for phase B, I will select phase B. If I have a demand for phase C, I will select phase C, irrespective of the fact whether like like which I can select phase D and then I can select phase B also. I don't have to follow the sequence at all. Obviously, you have to give a green to one approach, but I was surprised when you said everybody is red. You will have, let's say, the phase A is I'm always going to give green. But I'm going to select B, C or D if there is a demand for B, C and D. If no, A is always green because at the intersection something should always be green, right? So let's say A is there. When are you going to run such kind of approach? So approach I'm saying is for this intersection, let's say this A is always green, right? This approach, this movement is always allowed to go green. But if there is some demand for this one, I will cut off A, I will start this one. If there is some demand for, let's say, that one, I will cut off A, I will start that one. So I can start B, C or D anytime, but I can from A I can go to C, then I can go to B if there was no demand for it, then I can go to D if there's a demand for D. I'm not going to follow any sequence. When am I going to do that? Major minor node, yes. When else? Yes, major minor will do it, but when else we can do it? During the peak hours, if I do that, it is I'm disturbing. I mean, during the peak hour, I would like to have a coordination and I would like to have a proper sequence following. No, here there's no coordination. I'm talking about isolated one. There's no coordination. It's just I'm just giving like no cycle time and no phase sequence. Any phase present in the controller personality can be called by the corresponding detector. If there's a demand, when I say call by the detector, I mean let's say there is a call from here. These are the ones which are called, right? Imagine all of them are not called. All of a sudden there is a call for here. Then this phase will be given green. Less traffic in the late nights. In the night, you don't expect much traffic on the road. So you know that okay, for this approach, this is a main line or the main road. I will give a green in the night, and then if the demand coming from elsewhere, I will just serve them. Or when the traffic is very low, yes. Yeah.
So we have noticed in Bangalore after 10 o'clock it becomes yellow.
That blinking one, right? Yeah, that one is to see. You also do not want to give a green for a longer corridor. Why? People will drive very fast. It becomes very unsafe. In the night, people think there's no traffic. Even if there's a red, if they're high speed, they might like to go. No. So you would like to break that chain also. And that blinking one is to break the chain. Means that you basically have a look and then you move. You don't have to stop, but have a look and then move. So those strategies are implemented to actually for the safety point of view. So that's isolated one. I'm just telling you that different ways to handle it. That's one way. Other one is master isolated means there is no cycle time, but the phase sequence is pre-specified. I will follow my sequence. From A, if I go to C, if a demand comes for B, I will not go to B. I will go back to that one and then come here. So I will follow a sequence. Only a specific sequence can be called by the corresponding detector. Having some, I would say this is a automated traffic control software given to the road authority. So the traffic engineer has this tool in his hand. He or she will like to have more flexibility in terms of the way they want to control it, right? So that's another flexibility given to the person. You can control that way. Third one is a coordinated approach with actuation. In this case, the cycle time the moment I say it's coordinated, you will like to fix the cycle time. Because you cannot maintain coordination with a very imbalanced cycle time. So coordinated with the fixed cycle time and a phase sequence. But when you want to do the coordination, you have to specify the corridor you want to do the coordination. For example, I can specify this is the corridor I want to coordinate, or these are the group of intersections I want to coordinate in one go. So you specify that. But there are some engineering constraints for it. you will not like to coordinate intersections which are 2 km apart, very long, because the pattern will disperse. You will not have the benefit of coordination. Coordination benefit is only when the intersections are close by. Then only the benefit is. If they are very far apart, there is no benefit. Like CBD, intersection are close by, you like to coordinate them, but other places you don't have to. Now, this is one way of giving some flexibility to the engineer to make whatever they want to make, right? There can be other also. If you go to some other systems or more systems, you might have other layers, right? So that's one way of doing it. But I want to just tell you that as an engineer, you have a tool that you can use to adjust the timings or design your plan as you want to plan it. Then, yes.
Ultimately, everything is still going to be go with some kind of detector.
Yes, detector. Decision will be based on detector because that's the only eye you have. See, when I say automated system means I want to put a signal and I will let the detector make a decision, the software make a decision when to give green and what green and how long to give a green, whom to give green. So there will be a detector. It can be a loop detector, it can be a video camera, it can be infrared, it can be microwave, whatever it is. But that detector might be focusing on one, because these, at the end of the day, the algorithm behind this is might be looking at one specific location and talking about the presence, whether that is present or not. That's the only thing that it will be checking.
I was trying to understand if in case a detector breaks off,
Breaks off, yes, you will have that, yes.
then we can still have a full algorithm logic.
That's a fail safe. You always have a fail safe mode. Like in the case of traffic RAM metering also, there is a fail safe algorithm always there. So academically you can build whatever you want to, like whatever, but when you implement it, you always have a fail safe feature attached to it. What happens if there is some failure? If there is a failure, what will I be doing? Which approach should I be following? Yeah, is okay. Now this is another snapshot from Steam's Arterial for a specific day, 15th of February 2024. Let me take it off. You see all of them. You see for one of the intersections, although I try to hide number of things here just for but what you see here that this specific intersection from midnight to 5:30 in the morning will be working on a master isolated approach, right? From 5:30 to 7 o'clock you will have one plan, 7 to 8 you might have another plan, 8 to 9 you have another plan, maybe 9 to 10 you have another plan, and so on. Now see the amount of work involved into it. You have to define your time of the day, the cuts you are going to make, the temporal cuts you are going to make, and that's where a lot of survey is being done, or a lot of data that we are collecting can be utilized to understand the patterns on your network. This is for 15th of February, which is Thursday, right? If I go on, let's say 17th, a Saturday, you might have a different plan. So you have the whole year in front of you, and you say, okay, I have certain type of days with certain traffic characteristics. That's what we call the patterns in the system. And you want to identify the patterns. You want to see what patterns are there for what, how long they are there, and then you do a temporal boundary first, right? You have, in fact, for that site, because the engineer should know how the site is, and they might have observed that there is certain behavior from 5:30 to 7, 7 to 8 is something else, 8 to 9 is something else, and so on, which is obvious because traffic is building at that time. So they will say, okay, this is my first temporal boundary. For that temporal boundary, you need to have a lot of data set. You need to understand how much is the traffic moving, and this is for 15th of February. But you have other days also. Different days will have a different profile, but you might have clustered your days in a way. Let's say you say all my working Mondays or all my working weekdays with no school holiday. This is just a standard way to define. Working means people are working, means there is traffic. If it's a holiday, it's a different behavior. School holiday has a totally different behavior. The traffic is quite different when the school holiday is there, because people also take holiday and not morning traffic is there. not school pickup and drop off is there. So those behaviors are well known. So you define it for those time periods, right? So that's a pre-data collection you have been doing for that site. So I've done my temporal boundaries. Then this is telling you how even defining the phase, giving more flexibility to the operator. You have different phase sequence A, B, C, D. This is from the software, by the way, and the backend it just uses this value to do the changes. Phase A normally is always the first phase, normally the most demand phase. That's how you define phase A. Different tools or different software might have a different way of specifying it. I'm talking about this tool. 0 to 65 means I'm going to give a duration of 65 seconds, which you have optimized by some other means. I will discuss that or how you do the optimization also, but you have done the optimization by some other means. Release means you will not have an early cutoff. You are definitely going to give, you are starting a phase A, you're going to give a 65 seconds to that phase. You're not going to have an early cutoff for that phase because of number of constraints, maybe because of the coordination or something else. And this is up to the operator to decide. Demand tick means that there is always a demand for that phase, irrespective of the fact whether you are not observing any demand on the loop. So this phase will always be served. So if the demand is ticked, the phase is always served. If the demand is not ticked, the phase can be skipped if there is no demand. So now you can see I can have a lot of phases, but I can skip my phases if there is no demand. So in this particular case, B, C, D, and E can be skipped because I'm just telling the controller that if there is no demand, feel free to skip that one. Then B, in a normal cycle will start at 65, go for 14 seconds. C will start at 79, go for 26 seconds, and so on, right? But these can be skipped. But if B is served, it has to be served for 14 seconds because I have made it release no. Now these are the levers that the operator has. But C, D, E, and E are continuous. Continuous means if they are served after 3 seconds, you can cut them off if there is no demand. You need to serve them for, you will not have a green and all of a sudden red. Green, give green for 3 seconds, give a yellow for whatever 2 to 3 seconds, give the all red and cut it off. You are allowed to cut the other ones, but you are not allowed to cut A and B if they are served. That depends on the characteristics of the corridor, that depends on the way you are controlling it, that depends on the time of the day, the demand pattern, etc. That's one approach. You can have another approach where you can have a dynamic plan selection based on occupancy. Here you can say I can have different occupancies from approaches. Select a plan when the occupancy combination is this, and you have done optimization for that occupancy combination. There are multiple permutation combinations which are there. For that intersection occupancy or the approach occupancy, the way you have defined that. Again, this is a modeling you have to do, a lot of modeling to do whatever. So what I'm saying is you can have different combinations, right? I can I can have a default schedule for the time of the day. I can have like a roasting schedule. I can have a recurring override. I mean, there are number of features or flexibility that the software can provide to the operator to do those things. Now, what is early cutoff? Let's discuss what do we mean by early cutoff. Simple example, let's look at this video again. I only have one video actually for that one, that's why the green is for this approach, through and right turners. In fact, for this specific intersection, I will pause again. For this specific intersection, when I'm showing the video, a through movement already had a green, right? And after a while, maybe that movement also had a green. After a while, this is cut off, and now you're letting the other approach to turn right. Yeah. In this case, do you think you will have a permissive right turn allowed, or you will have a protective right turn? So this is actually a very 3 lanes here, so maybe there must be 3 lanes. In fact, there are 3 lanes on the approach, right? What do you think? If you are the engineer, are you going to allow a permissive. Permissive means the other approach can go through. This is also allowed to make a right turn. Will you be allowing a permissive right turn here? You will always allow protective for them, right? Why?
Because number of lanes are more and
Number of lanes are more, traffic is high. You will always have a protective there, right? You will not allow permissive. Although software wise you can do it, but as an engineer you know the site very well. You will say no way I will allow that. That's why that was a through that this was cut off, and now these guys are allowed to make a right turn. Yes? Yeah?
At this point, we can assume that there is a through going through this way also.
This one is going that way.
Would there be through at this moment? No.
Which through? This one? No. That was stopped. So I mean, because I did not have the full video, this one was perhaps first these two throughs were there, then this through was cut off, and then the right turners were allowed. That's why you can see when the green is here, already the queue has been dissipated for that one. These one are just running because there is a high demand for that one, but you can see that these one are just dissipating. Yeah. And that's actually a very heavy vehicle also running there, so you will have to design the intersection considering the traffic composition for the site. Also you have to consider, in fact this is a very typical example where when they take a right turn further maybe 300 meter 400 meter down, they have to take a left turn also, or they have to go through. A lot of traffic is going to take a left turn. So Brisbane drivers are very well behaved, as you can see here. The queue length here is much larger compared to there, because those traffic who has to go further down and take a further right turn, they normally will like to queue here, not there. There can still be some drivers who will do, but generally they will always try to do that way because they know they have to actually make a right turn, and that leads to underutilization of the lanes sometimes. But because that section is so short, it becomes hard for you to merge, right? Only I would say only there might be few drivers who do not know that way, they will, but generally most of them will actually be on the appropriate lane. Their look ahead distance is actually quite well. So far they are really well behaved.
Getting a driver license will be tough here.
Anyway, so yeah, so what I wanted to talk about was what do I mean by early cutoff? Think like this: I would like to have a flow where traffic is continually flowing, right? So continually flowing with certain amount of headway which I am expecting. It's a good flow, but this flow right now is not a very good flow for me, but it is okay because I have given a green, right? So it's not a very good flow for me. Now the timer that you allow is if there is a large gap happening. No, there are different ways of doing it. This is just one way of doing it. If a gap has exceeded a y value, maybe 20 seconds, 10 seconds, whatever you have specified, you say time to make a cut. Yesterday or day before yesterday, I was talking about the queue loop, the long queue loop. That long queue loop is to avoid that much holding. You say, oh, if I have already a long queue loop, why do I have to make y of 10 seconds? I can make a y of just 1 second, because I know that there's no demand for that much portion of the road. There's no queue left over, so I can do that one. So that's one reason why you want to go for a queue loop, the longer loop. Another approach is you are having a counter. The counter says that I'm expecting a kind of expected a good headway, safe headway, maybe 2 seconds, maybe 1.5 seconds, maybe 3 seconds, whatever I specify. Any extra headway is a waste. I want to minimize my amount of unused green. I will keep on counting it. The moment the extra waste has exceeded my my threshold, I will cut off. Now this is just a concept I am trying to explain to you, that there are different ways of doing it. Different tools, different methodologies or different models might have a slightly different, but the concept is cut off the green if you do not need it much. That's the concept. Yeah. So we can stop here, but I would like you to think about 2 questions which we will discuss, which we would like to answer later on. You have seen that you need to perform a spatial grouping, which is the groups you have to form, or spatial grouping also with respect to the coordination. What corridors to actually coordinate. So I might say I will coordinate only this much, or I will coordinate these, I will coordinate those. You have to form which corridors to coordinate. You also need to define your schedule, what time of the day you're going to do what kind of schedule. Now, so basically you have to identify both spatial and temporal boundaries for your signal design. And generally they are based on practitioner survey and practitioner experience, how much they know about the site and the survey that they do for the site. Can you think, we have discussed a lot about the data set, we talk about Bluetooth, loops, trajectories. Can you think that data analytics can really help us to come up with a systematic procedure to identify these boundaries? Just think about it. We will have a chat later on. I think it's a time for a break before we start something else. Yeah. Can we take a break or we continue? What? Yeah, check if the tea is there. We can take a break here. Yes, there's a question. Yes.
What is the price of loop detector or image processor?
I know the pricing. I will show you one slide later on where we have done a comparative. We have done the whole of life, not exactly the modeling of whole of life cost, but did a comparison over different sensing technologies. Loops are relatively very cheaper compared to the cameras with respect to the whole of life, because camera technology is cheap, no doubt, but their software upgrades and all those things are actually changing quite frequently. The whole of life is not 20 years. Loop can have a 20 years of as your life one, right? So after 5 years the software will change. There is a lot of cost involved in terms of the data processing and actually software upgrades. So they are comparable, I would say, but if you look at the whole of life, I would say loops are still cheaper. Not I would say that practitioners have said that to me. Yeah, but again it depends. For the Indian condition, I think camera should be a good way to go. The cost variation is not that huge. Loops are actually, loops are because our road is not, if road is not properly maintained, loops will fail quite frequently. Loops have to have a cut on the road, and if because of whatever XYZ reason the road is not properly maintained, your loop might not function properly. Whereas camera is a technology you put basically as a non-intrusive one, you put as an overhead or a side one, and you can perhaps easily manage. But cost wise, I would say they are pretty much the same. Yes, you have a question?
When on picking multiple pages, the traffic is high on both of them. So like the queue is unable to dissipate in multiple green tags.
Mm-hmm.
So in that situation, what should we do? If we are increasing the green tag in certain fields, the delay in certain fields is also increasing.
Yes.
So in that case, we should increase the green time based on the increase the queue is longer, or we should give some different facility. How should we approach it?
See, demand, delay, queue length, they are interrelated. If you go to the queuing theory, delay, demand, and queue length are dependent on each other. They are not very far away, right? If you are optimized, if you optimize for the demand, or if you optimize for the delay, or if you optimize for the queue length, it should, if the things are not behaving well because of the demand is so high for all the approaches, you have a totally oversaturated intersection. The intersection capacity is not strong enough to hold it. No matter whatever cycle or green you do, you cannot serve all the movements properly. So, and the oversaturated condition, you can't do much. But the system is not that oversaturated. That's the time when these things can give you an optimal solution. Yes, if some approaches have low demand and you're giving excess green to it, you can take the green from that and give it to other one. So that's what you can do, and that's what I will discuss later on, that you try to come up with different data analytics to understand that there is some room for improvement. But if the system is oversaturated, you can't do much.
But it is ready.
So shall we take a break or yeah? So we will. How long we break? 10 minutes? 15 minutes? 15? Okay. So right now it is 10:40. We start at 10:55. Yeah. So online audience will have a 15 minutes break. We start at 10:55.